Hey guys, so on Monday we talked about section 11.3, the tangent line problem, where we focused on visually looking at a graph and seeing what the slope of the tangent line would be at particular points. We noticed that we made use of that difference quotient that we talked about last week and earlier in the year, and how that relates to the slope of the tangent line of your graph. So if we are looking at a specific point, we used this equation right here. Notice that we plugged in f of c into our difference quotient there. If we want to know the formula for the slope for the entire equation, we would use this one. So looking at specific examples back from Monday, if we were looking at the slope of our graph of f of x equals x squared at a particular point, we would use this equation right here, where we did f of c plus h minus f of c. If we want to know the formula for the entire equation, we would use the bottom one here. So, formula for the slope. The last two examples we did on Monday were aligned, so those slopes were the same for the entire function. However, we're going to be able to use this formula right here for a slope of a tangent line of, say, a quadratic function that changes based on where you are on its graph. So let's take a look at an example for that one. So find a formula for your slope of your graph f of x equals x squared plus 1. Write this down. We're finding the formula for the entire graph, the slope of the tangent line of the entire function f of x, and then we'll be able to use that to find the slope at particular points. So we're going to use that second equation that I just talked about. So the slope of our secant, so our tangent line, of f of x plus h minus f of x, all over h. And we have to remember that that is talking about when h is approaching 0. So we can remember the limit. Alright, so plugging in x plus h in for x, and then going back and plugging in x, which is just your original equation of your function. Here is what you have here. So x plus h squared plus 1 minus your function, your original function there, all over h. Foiling this, x squared plus 2xh plus h squared plus that 1. Got to remember to distribute a negative 1 here. That's why these are both negative. Combining like terms. Looking in our numerator here, I see a positive x squared and a negative x squared, a positive 1 and a negative 1. So this here will be 2xh plus h squared all over h. Noticing that there's a common factor of h in our numerator, we're going to factor out an h. Cancel our h's. So our limit as h approaches 0 of this 2x plus h. Notice we don't have h in our denominator anymore, so we don't have a domain restriction there. We can use direct substitution. So this slope will be 2x. So let's recap for a second. We plug in x plus h into our function, plug in x into our function, which is just our original function. Simplify. Be careful not to forget about distributing a negative here. Simplify your functions. Combine like terms. I'll give you a hint. You can always notice that the terms that have no h's in them will be eliminated. Next step, factor out an h, cancel with the denominator, and then once your denominator is eliminated, cancel those out and use direct substitution. So our slope of the tangent line of our function x squared plus 1 will be 2x. So if you notice here, here's our graph. So our slope is 2x. We have to remember that. Now the question asked for the points. Find what the slope is at particular points, -1, 2, and 2, 5, which are written right here. So the slope at this first point, which I'm going to highlight in blue, is 2 times x, and our x value we have is -1. So at -1, 2, our slope is 2 times that -1, so our slope is -2. So this pink line, which I'm going to highlight in blue, this line is your tangent line to your graph at point -1, 2, has a slope of -2. The slope of your tangent line at point 25 does not have a negative slope. It is this line right here. That is a positive slope, so that slope's different. So we are going to plug in, all right, at 2, 5, our slope of our tangent line of our graph x squared plus 1 is going to be 2 times 2, which equals 4. So that slope is 4 of that green line. We're just talking about the slopes right now. Notice we didn't do anything with our y values. That's going to come on later on this section or chapter. All right, practice problem. Hit pause and try to go through finding the formula of the slope of this function 2x squared minus 3. Find the formula for the whole equation of our tangent line for that graph, and then we'll come back and check to make sure that your equation was correct, and then we will find what the slope is at those 2 points, -3, 15, and 2, 5. All right, going through here. F of x plus h minus f of x all over h for our slope. I plugged in x plus h into x in my function. I'm subtracting just your function, which is f of x. So we have to FOIL, distribute the 2 to each piece, distribute this -1 to each piece. I canceled it out and simplified, combining any like terms. 4xh plus 2h squared all over h. I factored out the common factor of h, canceled it. So we're looking at our limit as h approaches 0 of 4x plus 2h. You can use direct substitution, plugging in 0 for h. So the equation of the slope of the tangent line of our function f of x is 4x. All right, so we are asked to do -3, 15, and 2, 5. So our slope at 3, 15, plug in 3 for x, so this slope is 12. At 2, 5, our slope is 4 times 2. Oh, this was -3, 15, correct? Yeah, -3, sorry. -3, so the slope is -12. Over here at 2, 5, our slope would be 8. All right, so the derivative of a function. We started with earlier the function x squared plus 1, and we used the limit process to derive the equation of our slope of the tangent line of x squared plus 1 to be 2x. This is the slope of our graph of the tangent line at a particular point that we plugged in later. So we plugged in 2 points. This function, 2x, is called the derivative of our function. And we use this notation here, and we say that out loud as f prime. So it's a little tick mark. So the official definition of a derivative of your function at x is given by this equation right here. Please write this definition down. Always make note, this is as long as our limit exists. The thing you really need to remember is f prime of x is your derivative of your function f, is the slope of the tangent line of your graph at the particular point x. All right, let's do one more example here. So now we're finding the derivative of our function here. Write this example down. All right, so we are going to be using the official definition, limit as h approaches 0 of f of x plus h minus f of x. I forgot to write that in there. Let's see if I can move these. Oh, there it is. There we go. So f prime of x, our derivative of our function, is f of x plus h minus f of x all over h. The limit as h approaches 0. We plug in x plus h into both of these x's here, minus f of x. So just notice I just replaced these x's with pink x's, so you see that's just the exact same equation there. FOIL would be x squared plus 2xh plus h squared, multiplying each of those three pieces by 3. So 3x squared plus 6xh plus 3h, minus 2 times those right here, and then distributing a negative to the f of x function here. Combining like terms. Remember the hint of all of your non-h terms should go away. So 3x squared and a negative 3x squared, negative 2x, positive 2x. So the limit as h approaches 0 of these final three terms in the numerator, notice they all have an h term in there. Factoring out an h would result in these three remaining terms here. Cancel out an h. So now we have the limit as h approaches 0 of 6x plus 3h minus 2. We are now allowed to use direct substitution, so go ahead and plug in 0 in for h. So 6x plus 3 times 0 minus 2. So our f prime of x, so the slope of the equation of our tangent line of our function, is 6x minus 2. That is our derivative of our function 3x squared minus 2x. So it's the exact same process. Now we just have the notation f prime of x to denote that we are finding the derivative of our function. And then if you are asked to find what the slope of a tangent line is at any particular point, so say the slope of our tangent line to our function f of x at, say, the point 3, 7, you can now use your notation of f prime of 3, and you plug in 3 for x, just like we did in the previous examples. All right, let me know if you guys have any questions, and I hope you have a great day. Thanks, guys.